Alright, what's up, guys? Today I'm going to be doing lesson 8.5, which talks about compound interest. One of the things that you guys continuously tell me is, when are we ever going to use this math stuff in real life? And this lesson is going to be one that is very applicable to what you guys are going to have to do in the future, which talks about interest rates, specifically compound interest. So let's take a look at it. So a common application of exponential growth, this is something that we talked about in Unit 7, is compound interest. So compound interest is money that is earned or paid on both the principal and any interest that was previously earned. Previously earned interest. So I'm going to be talking about what all of this means as soon as I start defining some variables. But before I go all crazy with the variables, let's just talk about E for a second. So we've been talking about this number for a while. Number E refers to an irrational number. And it is written as a symbol E, similar to how pi is written with that symbol. So normally we use that number to see exactly how interest rates work. And they are also applicable with population rates. So this is how the number E gets formulated. And this is just a bit of calculus. We have the variable n, and we set a limit as n approaches infinity. So that part isn't exactly important for you guys to know, but just understand that it's a precursor to calculus. And of course, the GOAT, Jacob Bernoulli, proved that E gets close to that value. These are some properties real quick that will be important for us to recall. So e to the power of 0.5 is actually the same as e to the power of 1/2. That's actually going to be the same as radical e. Next one, we have e squared times e to the 5th. And since they both have the same base, which in this case is e, and we're multiplying, we are adding the exponents. Finally, e to the 4th divided by e squared. Well, if before then we added when we multiplied, this means that we subtract because we're dividing. So we get e squared here. Okay, so that's just a few little problems to touch base on our properties. Now let's talk more specifically about the equations that we will be using to calculate compound interest. So we have two equations that we'll use to find compound interest, and it's going to depend on how the interest is compounded, either continuously at all times or through various time periods. So let's first look at compound interest continuously. So let's say we invest $P at an interest rate. Let's say we invest dollars at a continuous rate. At an interest rate compounded continuously. And that means our money is going to be worth P times e to the RT. That's simply the equation right here. So this basically means that interest is going to be added into our account at every single moment. Now, if we are compounding based on time periods, then if we invest dollars at a certain interest rate and we compound it periodically, and periodically, remember, we could think about it as like time periods. So every single day we have school periods. And they're regular. Every single time they're regular. So it's going to depend how many periods we have depending on the type of time periods we're talking about. So let's say annually. Well, annually means once per year. Semi-annually means twice per year. Quarterly means 4 times per year, and so on. There's 12 months in a year, 52 weeks in a year, and 365 days in a year. This is just an example of certain different time periods, but they're the most common. However, there could be different ones depending on whatever time periods that we decide to use. And now let's define the variables. We have a bunch of letters in the equation. What are we even talking about? So first of all, the money that we are concerned with is defined by A. So A means balance after a certain amount of time passes. So after T years. So if we invest a certain amount, we want to know how much it's going to be after some certain amount of years. And A is an important value. Now P refers to the principal, which is how you guys will probably see it in the future, or just means original amount. AMT dot. Original amount. Rate, I'm sure you guys could guess it. It's going to mean, or R is for rate, rather. But it's going to be important for us to express it as a decimal and not a percent. N means number of times interest is compounded. So if we have an annual interest, that means every year it's going to compound once. All the interest is collected once. If it's monthly, well, then the interest is going to be compounded every month. So there's 12 months in 1 year. So it's going to be 12 times that it is. Next up, T simply means years. How much time passes in years? So let me be specific with that. Time in years. And finally, E is about 2.718. And then just do dot, 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 dot. So now that we've defined all of these variables, let's try to answer some of these example questions in the back. So let's first analyze our question and see what variables we are given. Imagine that we invest $500 at a 4.5% annual interest. Calculate the amount that we would have after 2 years if it's compounded on several different types of time periods. So, okay, $500. That is how much we initially invested. That is our principal. We have a rate of 4.5%. But just remember, we want to move that decimal twice over. So that actually means 0.045. And that is actually our rate. Our time is, 2 years, right? 2 years. That's how much time we have. And based on all of these values, as well as the time increments, we can just use the equations from above so that we can answer the question of how much money we would have. Remember, that refers to A. A is asking us how much money do we have. So let's see, if we are compounding every month, that means there's 12 months in a year, so N equals 12. So let's check it out. A is equal to P. Well, not P. We already know that our P is 500. 1 plus my rate is... Actually, I made a mistake over here. It is not 0.45. It's 0.45. All of that divided by 1 to the power of 1 times T, which we know that T is 2 years. So this is actually going to be 1 point. Actually, it's not relevant for us to write it like that, because at this point, I'm going to want you to plug this into your calculator so that you could give me the answer. And I'm going to want you to round to at least 2 decimal places. But for this question, we're going to get 547, whoops, not comma, .00. So we invested $500, and it looks like we got about $47. And that's what happens when we compound our interest monthly. But daily refers to 365. So let's see how that looks. So we still put in our 500. We do 1 plus point, what is it? 0.045 again. But this time we divide it by 365 because that's what the equation tells us to do. That's to the power of 365 times 12. Plugging all of this into the calculator, we get 547.08. So it's a little bit more than the daily, just a few cents, but still. Why would we pick less money? More money is always good. But let's see what happens when we compound continuously. So it's going to be A, but this time we're going to use the other equation. So we still have 500 as our principal. We have our E, which is just a number, to the power of 0.045 times 2 years. Forgive me, I wrote 12 back here. It should just be 2. Once we plug this in, we get a value of 547. Let me write a little dollar sign on that. 547.09. So just a tiny bit more. Nevertheless, it's not bad. So those are some straightforward questions. We just use the equations to plug in we use the variables and then we use the equations after plugging them in, and then we just type that into the calculator. So just make the note. Type into calculator this one, and this one. All right, last 3 examples of the notes. We are going to consider this question where we initially invest $800. Our interest is 0.07 after moving the decimal. And finally, we are given our A. So this question turns it around a little bit, meaning that we want to know how much time it's going to take us to reach a total of $2,000 for our A. So now let's consider each question carefully. So it's asking us if we compound yearly, well, that means we know that 1 year passes by per year. So we're going to use the equation, the top left. So, okay, we use 2,000 is equal to the principal, which is 800. Then we do 1 plus 0.07, all of that divided by 1 to the power of 1 times t. Now, what we need to do is we need to do something very similar that we've been doing in all of our homeworks, which is we want to isolate our base and exponent. So we end up with something that looks like this. So actually, let's just write it like this. 1.07 to the power of t is equal to, then we did 2,000 divided by 800. And the reason I divided by 800 is because we want to isolate our base. And that means that times 800 in the front, this one right here, needed to be canceled out. And the opposite of times 800 is divided by 800. And whatever you do to one side, you do it to the other. And that led us to this new equation. Now from here, we just solve it the same way we've always been doing it. So the log and my base in this one is going to be this. 1.07. Parentheses 2.5, and it's always equal to the exponent, which is t. So we get this log, and if we were to plug that log into the calculator, you would notice that we would get 13.54 years. So this would be your answer. We want to just be plugging in our log, and we would get a time in years. So next one, let's see what happens when we compound quarterly. And quarterly means, well, there's 4 quarters and things. So we're going to compound 4 times in 1 year. So again, we set it up the same way, just using our new n. And it's going to be very similar. We want to divide by the 800 on both sides so that we cancel it out, so that we end up with just the base. And when we write just the base, it's actually going to be something like this, 0.175. This is what we get when we calculate this little part inside of the parentheses. Let me just double check to see if it's that for sure, but I believe that is the right value. So we get 1 plus, then parentheses, 0.07 divided by 4. Yes, perfectly right. So we get all of that to the power of 4t, and that's equal to 2.5. And from here, it's the same type of question. We have log base 1.0175 of 2.5, and it's equal to 4t. No one in the history of humanity has anybody cared what 4t equals to. We want to know how much t equals to. And the way we cancel out this 4 is we divide it by 4. And whatever you do to one side, you do it to the other. So we get t equals log of 1.0175 of 2.5 all over 4. And plugging that into the calculator, we actually get 13.20 years. That's what I'm going to box in. Whoops. 13.20 years. Last one, if we are compounding continuously, that means we are using the other equation, which is going to look like this, 0.07 times t. We have an e this time, but no matter, we just work with it the same way we've always worked with it. We end up with, after canceling out the 800, e to the power of 0.07t, which is equal to 2.5. Same thing. We have a log base e, so we could actually write that as ln, and then parentheses 2.5, and it's equal to 0 or 0.07 times t. And the way we cancel out that 0.07 is divide on both sides. So t equals ln of 2.5 divided by 0.07. If you plug that into the calculator, you see that we get 13.09 years. So notice that depending on the type of compounding equation that we use, we actually get different values for how much time it will take us. So we are still investing 800, still has a 7% interest rate, and we still are trying to reach 2,000, but they all result in different years, different times that it's going to take us. And just a reminder, you want to type everything into calculators, whether it be a Desmos or one of those TI Inspires. Okay, so now I'm just going to do one of the questions off of the homework so that you guys get a jump on it, just so that you guys are not intimidated. So let's just start with this second one. The first one is not too bad. The second one is also not too bad, but I'm just going to do it anyways. So the Bad Bunny company has a savings plan for their employees. Employee makes initial contributions of $2,500, so we know that that is the principal, 2,500. We know that it is a 7.5% interest rate, so we can rewrite that already as a decimal. And it compounds weekly. So weekly, that tells us that our n is going to be 52. There's 52 weeks in 1 year. And just so that we label all these things, let's be clear. So yes, 52 for n. And a is what we are trying to end up with. So we end up with 5,000. Using all of these values, we are going to plug them into our equation, which should be this one. The one on the left, just for this first question because it's compounded weekly. And let's just plug in everything. So our A is 5,000. It's going to be equal to principal, which is 2,500 times 1 plus, let's see, R is 0.075 divided by 52 to the power of 52. And we are trying to find T. That's what we're trying to find. And now from here, we want to divide the 2,500 because we don't want it in the front. We want it on the other side. Whenever you do to one side, you do it to the other. And also, when you simplify that little parentheses thing with the 1 plus 0.075 divided by 2, or 52, you end up with 1.0014. So 2 equals 1.0014 to the power of 52t. As soon as we end up with this, we want to rewrite it as a log. So here we have a log of base 1.0014. That's my base. Parentheses 2, and it all equals the exponent, which is 52t. Finally, we end up with this last step where we divide by 52 on both sides. And we end up with this expression. T equals log 1.0014 parentheses 2 divided by 52. So that is basically your answer, but I want you to plug that into a calculator and tell me what the value is. And you're going to write it down there. So try to use this process on every single one of the questions. Sometimes you might have to use a log, other times you won't. It's just depending on whether your variable is in the exponent or not. So that's the big hint. If you have a variable that you don't know in the exponent, then that means you have to use a log. Otherwise, you could pretty much just use the equation straight up. All right, good luck.